Hi students, I am Anju, your math teacher. I welcome you all to this session. First of all, before going to this topic, we should know what are the basic operations in mathematics. The basic operations in mathematics are the two basic arithmetic operations in mathematics are addition, subtraction, multiplication and division. In those basic operations, we are mainly focusing on division in this session. Now, there is a math rule to know more about division, which is called divisibility rules. Now comes our divisibility rule. First of all, we should know what is meant by divisible by. If a number is divisible by means, if we divide one number by another, the result is a whole number without a remainder. If you divide one number by another number, we will get the quotient as a whole number, but we won't get any remainder. Our remainder will be 0. That is called as divisible by. Here are the divisibility rules for each and every number given. Each divisibility test will be explained in the upcoming pictures. First is the divisibility rule for 2, the number 2. If a number is divisible by 2, then its last digit is even. If a number's last digit is even, which means 0, 2, 4, 6, 8, then we set that number as divisible by 2. Here is the example given, 78. What is the last digit of 78? 8. 8 is an even number. So obviously 78 is divided by 2. It is divisible by 2. Like 3470. Here last digit is 0. 0 is also an even number. Therefore it is divisible by 2. 3470 is divisible by 2. Next is the divisibility rule for 3, the number 3. A number is divisible by 3 if the sum of the digit is divisible by 3. So here we have to do the sum of the digits. Example is 75. Here listen, if you are adding 7 and 5, we get answer as 12. Actually, 12 is divisible by 3. If we divide 12 by 3, we get quotient as 4 and remainder as 0. So, 12 is divisible by 3. Obviously, 75 is also divisible by 3. If the sum of the digits are divisible by 3, the number is also divisible by 3. Next example is 369. If we add these 3 digits, we get 18. If 18 is divided by 3, yes, of course, because our answer quotient which we'll get is 6 and our remainder will be 0. So obviously 369 is divisible by 3. The next divisibility rule is for number 4. A number is divisible by 4 if the last 2 digits are divisible by 4. So we have to check the last 2 digits here. Example is 1320. Here what is the last 2 digits? 20. So if we divide 20 by 4, we get quotient as 5 and remainder as 0. So 20 is divisible by 4. Therefore 1320 is also divisible by 4. Next example is 672. Here last 2 digit is 72. I am dividing 72 by 4. Our quotient is 18. So our remainder will be 0. So 72 is divisible by 4. Therefore 672 is also divisible by 4. The next rule is divisibility by 5. A number is divisible by 5 if the last digit is 0 or 5. which means our last digit should be either 0 or 5. Then it is divisible by 5. Example for that is 615. What is the last digit here? 5. So 5 is divisible by, so the rule is the last digit should be 5. So we are saying that 615 is divisible by 5. Next example is 1480. The last digit is 0 here. So as per the rule, the last digit, either if it is 0 or 5, then the whole number, the whole thing will be divisible by 5. So 1480 is also divisible by 5. The next rule is about the divisibility by 6. A number is divisible by 6 when it is divisible by 2 and 3. It should be divisible in both the tables, like 2 table as well as in 3rd table. Example is 408. Here its last digit is 8, which is even, so it is divisible by 2. But if you add those digits like 4 plus 0 plus 8, you will get 12. 12 is divisible by 3. Therefore, since it is divisible by 2 as well as 3, we can say that this number 408 is divisible by 6. So, it should be divisible in both second table as well as in third table. That is a condition. Next rule is divisibility rule for 7. A number is divisible by 7 if its unit place digit is multiplied by 2 and subtracted from the remaining digits, and the number which will be obtained is divisible by 7. Example for that is 343. Here unit place is nothing but ones place. So what is the ones place value here? 3. So I am multiplying that ones place value with 2. What is the answer we are getting? 3 2s are 6. And by that answer, I am subtracting from the remaining digits. Remaining digits are 34. So I am subtracting from 34, I am getting 28. Here 28 is divisible by 7. So 343 will be obviously divisible by 7. The next rule is about the divisibility rule for 8. If the last 3 digits form a number divisible by 8, then the number is always divisible by 8. So, example for that is, here we have to take 3 digits, last 3 digits. Example is 6328. Here what is the 3 digits here? Last 3 digits here, 328. If we divide the 328 by 8, we'll get quotient as 41 and remainder as 0. So obviously 328 is divisible by 8. Then we can blindly say that the whole number, whatever the number it is given, that will be divisible by 8. Here, therefore, 6,328 will be divisible by 8. Next comes the divisibility rule for number 9. A number is divisible by 9 if the sum of the digits is divisible by 9. Here, so we have to consider the sum of the digit as like number 3. Example for that is 963. So first I am doing the sum here. 9 plus 6 plus 3, 18. 18 is actually divided by 9, which will get remainder as which will get quotient as 2 and remainder as 0. Therefore 963 is divisible by 9. The next example is 5445. Now I am adding individual digits like 5 plus 4 plus 4 plus 5. We get 18. 18 is divisible by 9 because 9 2s are 18, right? So that whole number, which is 5445, is divisible by 9. Next is the divisibility rule for number 10. A number is divisible by 10 if it n number, which means last number is 0. Like number 5, 10 is also like similar to that. Example for that is 7630. What is the last digit here? 0. So if the last digit is 0, then it is obviously divisible by 10. Next example is 410. Last digit is 0 here. Then it will be divisible by number 10. Here comes the divisibility rule for number 11. If the sum of one set of alternate digits and the sum of other set of alternate digit differ by 0 or 11 or a multiple of 11, then the number is divisible by 11. So first we have to do the sum of one set of alternate digits. Alternate digit is nothing but I am leaving one digit in between and I am adding. That is the thing. If I am getting the sum of one set of alternate digits and other set of alternate digit, and if I do the difference between those two, if my answer is 0 or 11 or multiple of 11 like 22, 33, 44 like that, if it comes means then that whole number will be divisible by 11. Example for that is 9262. Here alternate digit is 9 and 6 is one alternate digit. 2 and 2 is another alternate digits because I am leaving one digits in between. I am adding 9 plus 6, my answer is 15. Then 2 plus 2, 4. Then I am doing difference between these two. Difference is nothing but I am doing a subtraction like grade 15 minus 4. What is the answer? 11. So if we get there 0 or 11 or multiple of 11, then the number which we are doing this operation is divisible by 11. So 9262 will always be divisible by 11. In this session, we have discussed about the divisibility rule for many numbers like number 2, number 3, 4, 5, 6, 7, 8, 9, 10, 11. And this divisibility rule also explained with example problem also. So I think so you people can able to solve this problem by using these divisibility rules. Thank you children for your cooperation. Have a beautiful day.